Number 2, we're going to start with the graph. The first thing we're going to do is we're going to write the equation for this table. So we need to identify our y-intercept and the slope. For this table, it's a little bit different than the ones we've done before. As we look at the change in y, if I'm at 5 and I move to 5, it's changing how much? 0, because I'm still at the same spot. And we change in y is the rise. So my rise is 0. Then we have to look at the change in our x values. X's are changing by how much? 1. This change is the run. So this is my run. 0 divided by any number equals 0. So we know that the slope is 0. To figure out the y-intercept, or the b part, we're trying to figure out what's the y when x is 0. Anybody know the y value when x is 0? 5. It's right here. Sometimes it's at the top of the table. Sometimes it's somewhere in the middle. Sometimes it's somewhere at the bottom. But our y-intercept is 5. Now that we have these two pieces of information, we can write our equation. Anybody know what the equation is knowing that is 5 and 0? Just y equals 5? But what's our slope? 0. So I can have 0x plus 5, or simply y equals 5. Remember, lines that have a 0 slope are horizontal flat lines. The next part is we're going to graph this line. We're going to go to the y-axis, and we're going to identify where y is. If I try to use this here, my rise is 0, but my run is 1. I don't go up or down, but I run 1. This is what 0, 1 means. It's going to be a horizontal flat line that crosses the y-axis at 5. The next step is to solve the system of equations by substitution. I can choose to use this one or this one in this case. I'm going to go this one with less terms in it. We know that y is equal to 5. Y is equal to 5. We're going to substitute in for y right here. And we're going to solve for the other variable. So we have 9x plus 3 times whatever y is equal to negative 12. What value am I going to put in here? Just a 5. Then I'm going to simplify as much as I can. What's 3 times 5? And then we bring everything else down. Since we're trying to solve for the only variable we have here in this step, what's our next math use? Okay, subtract 15. I have 9x equals negative 27. Since they're both negative, we add them and keep the negative. And then what is our next math move? Divide by 9. So we have x is equal to negative what? This one we typically take the x value, we're going to substitute it back in. I can put it in here, but I already know that y is equal to 5. So since y is equal to 5 and x is equal to negative 3, my solution should always be as an ordered pair. Is it going to be 5 comma negative 3 or negative 3 comma 5? Negative 3 comma 5. Okay. So then the next part is we have to graph, or we have to solve it by graphing. In order to do that, we're going to take our equation given to us in standard form, And we need to convert it to slope-intercept form. So I have 9x plus 3y equals negative 12. And I want to convert this to y equals mx plus b in order for us to graph this one. If I want to get the term 3y by itself, what's the first thing we're going to do? Subtract 9x from both sides. So that leaves us 3y here. This is a constant without a variable. This term has a variable. They're not the same, so we're going to keep those separate. And what's our last move to get this to look like slope-intercept form? I'm going to divide all terms by 3. A negative divided by a positive is negative. How many times can 3 go into 9x? A negative divided by a positive is negative again. 3 can go into 12. So now that we have this equation in slope-intercept form, we know that the y-intercept is negative 4, and we know that the slope is negative 3, which I can represent over 1 to have rise over 1. So now we have the information we need to graph the second equation. So I'm going to start on the y-axis at negative 4. The rise is 3 over 1. It is negative, so I'm going to go down 3 and 1, and then 3 and 1. Since I don't see it intersecting with the line yet, I can also go the opposite direction. I can rise 3, but I have to go to the left once. So 3 and 1. And then I'm going to keep putting these lattice points until I can't fit them on my graph anymore. And for my second line, I'm going to come up these points. I do see that these two lines intersect or cross right here. And the coordinates for that point where they're intersecting, if I go straight down, I get the x value of negative 3. If I go to the right, I get the y value of 5, and it matches our previous question. Okay, once you have that, go ahead and flip to the back side. There's some corrections that we need to make on number 4. So this one was an example when they give us a table. Number 4 is an example when they give us a line already on the graph. So the first thing I need you to do is I need you to strike through that equation. It should have been 4x plus 10y equals 20. So step number 1, we're going to write the equation for the given graph. This time instead of the table, they give us a graph. We're still doing the same thing. You have to identify the y-intercept b and the slope m. If I draw my little stick figure here, is it walking uphill or downhill? Downhill. So I know it's going to be a negative slope. What is our y-intercept? It's crossing the y-axis here at negative 5. So our b value is negative 5. To find the slope, I need one additional lattice point. And remember, it's exactly where it crosses the intersecting lines. So I have a point down here, or I have this point up here. Some students kind of wanted to do this point here, but it's in between. It's not a lattice point. I'm going to draw myself a slope triangle here. What is our rise here? And what would be the run? So if I write my slope, which is the numerator? It's going to be 2, so that means the denominator is 5. Now we have all the information we need to write an equation for this given line. Anybody have that equation? Okay, the next part is we're going to solve this equation by substitution. We're going to take this part of the equation and we're going to substitute it in for y right here. So we have 4x plus 10 times, instead of y, we're going to put a negative 2/5 minus 5, and that's all equal to 20. So we're going to have to do a little bit of distributive here. If I distribute here, what's 10 times 2? And what's 20 divided by 5? What is a positive times a negative? And what's 10 times negative 5? And then I'm going to bring everything else down. Next, we have to combine like terms. I have a 4x and a negative 4x. What happens with those two terms? Cancel out, they're opposite. Is a negative 50 equal to a 20? So how many solutions? No solution, no solution. We also have to justify by graphing that this system is a no solution. We're going to take the standard form of this equation given, and we are going to convert it to slope-intercept form. In other words, we need to solve for y. What's going to be our first step to do that? Subtract the 4x from both sides. So we have 10y is equal to negative 4x plus 20. I have to keep these two separate because they're not like terms. What's our next math? Divide all terms by 10. So y is equal to negative 4 tenths x. How many times can 10 go into 20? 2. What's the y-intercept of this equation and what's our slope? Y-intercept is 2. And our slope is 4 over 10. I can also reduce this fraction. 4 tenths is also equivalent to 2/5, negative 2/5. I'm going to go to the y-axis. I'm going to start with the y-intercept of those two. I can use this one and go down 4 and to the right 10. Or I can do this one where I go down 2 and to the right 5. Then I can go opposite. I can go up 4 and to the left 10. Or I can go up 2 and to the left 5. Either way, if I connect these points, we notice that the lines are parallel. Parallel lines will never intersect. So this confirms that this is